So today, we're going to go ahead and review finding the greatest common factor. The reason why we keep reviewing finding the greatest common factor over and over again is because a lesson that we're going to learn on Monday, you're going to use the greatest common factor to fill out an entire area model. So we're going to do a quick review of finding the greatest common factor, and then we're going to do a review of area models, working them backwards. So let's look at the first part. We have 35, 49, and 77. So Alyssa, yeah, pull those forward. Get your blue cheat sheet out. I call the blue sheet your cheat sheet. You're going to use this prime numbers to help you factor the following three terms. So we have 35, we have 49, and we have 77. I want to know what the greatest common factor is going to be for these three numbers. So what I'm going to do is look at my blue cheat sheet, and I'm going to find the prime numbers for each of the following terms. So what are my prime numbers for 35, Stanisha?
5, 7, and 1.
I don't need to put 1 on there. What are my prime numbers for 49? Keep going.
3, 3, 5.
For 49?
Oh, that's why. 49. Oh, 77.
And then for 77?
7.
All right? So once I found my prime factors, I'm going to circle a group that has every single number in common. So 35, 49, 77. What prime numbers do they all have in common, Stanisha? 7. So I'm going to circle my group of 7s. You could circle that group, or you can include the other 7, but you only have one group of 7s that they have in common. So I'm going to come to the right. The greatest common factor for these three terms is 7. That's your final answer, so you're going to box it. That was an easy one. Now we're going to get and make it a little bit more difficult. So now we're going to find the prime factors for 42, 66, and 6. So we have 42, we have 66, and 6. But after we find these prime factors, we're going to have to come back and also find the greatest common factor for the variables. But we'll worry about that in just a second. So Zach, what are my prime numbers for 42?
2, 3, 7.
2 times 3 times 7. Okay, what about for 66?
2, 3, 11.
So 2 times 3 times 11. And then for 6?
2, 3.
So 2 times 3. Okay, Zach, what do they have in common?
2.
So they have a group of 2's in common. So they share 1, 2, and they share 1, 3. So I come to the right. The greatest common factor is 6, because I'm going to take the group of 2 and multiply it by the group of 3 to get 6. Okay? From here, I now need to look at my variables. Zach, do they all have an a in common?
Yes.
Yes. What is the variable with the smallest exponent?
3.
So a to the third.
Your thing like slow.
Is it lagging? Do they all have a b in common, Zach? What's the one with the smallest exponent?
2.
And then do they all have a c in common?
Yes.
Which is the variable with the smallest exponent for c?
4.
So c to the fourth. So the greatest common factor is going to be 6a cubed b squared c to the fourth. Feeling pretty confident about these. We all have it down? All right, moving right along. You're doing the exact same thing. You're finding the greatest common factor of the terms. You're not doing anything else with it. You're not worrying about the add or the subtraction sign yet. But guess what? Come Monday, you will. All right? So come Monday, we're going to do more with this, what you see up on the board, but not today. I'll give you a 3-day weekend to recover before we learn this stuff.
Mr. House says that too. He said he's giving us a day off.
I'm giving you a day off. I wish I had a day off. Okay, so what do we have for 20? Paige, what are my prime factors?
2, 2, 5.
And my prime factors for 36?
2, 2, 3, 3.
And what numbers do they have in common?
2. Another 2.
So my greatest common factor will be,
4.
okay, then let's look at our variables. Do they all have an s in common?
Yes.
S to the what?
3.
And then do they all have a t in common?
Yes.
T to the what?
1.
Do I have to put the 1 there?
No.
Can I?
No.
Final answer. Good. Moving right along. All right. Kijan, what are my prime factors for 60?
2 times 2 times 3, 5.
Okay, for 96?
2 2s and 2 3s.
Okay.
5 2s and 1 6.
Wait, for 96, that's it? 2 2s and 3 3s? 2 times 2 would be 4. 4 times 3 would be 12. 12 times 3 would be 36.
I said 2 3s.
Oh, that's for the...
It's 5 2s.
For 96?
Yeah.
Erase. Okay, so I'm on 96. So 5 2s.
1
So
3.
1, 2, 3, 4, 5. Is that better? Okay, what do they all have in common? Kijan?
2.
Yeah.
What's up?
Yeah, it's supposed to be 6, 3.
Okay, there's a mistake. Okay, so 96. Why would 6 be inaccurate? What's the sheet list?
Prime factors.
Prime factors. 6 is a what?
Prime number.
A prime number. So if 6 is a prime number, scratch the 6 out. It should be a 3. Not a 2 and a 3, just a 3.
So you say I don't know.
So on 96, the prime numbers for 96, scratch the 6 out. It just should be a 3. So in place of the 6, put a 3. So how many 2s do I actually have? 1, 2, 3, 4, 5. Should I still have 5 2s? Somebody in their calculator take 2 times 2 times 2 times 2 times 2 times 3. Multiply those together. Multiply all the prime factors that I have listed for 96.
96.
And I get 96 if I multiply all those numbers together? Okay, then our prime factors that Kijan gave us is correct. Okay, so, sorry Kijan. I forgot that there was a mistake on that sheet. I'm glad you guys saw it. Kijan, now what common factors do 60, 96, and 36 share?
4.
No,
8.
no.
Oh,
Stop.
6.
Start at the beginning. I'm going to circle my factor.
Oh, he timed it.
Yeah, he is. He's just a step ahead of me. So what factors do I circle?
2.
A group of 2s. Okay. What else? Is that all they share is 1, 2?
Yeah. Oh, no, 2 2s.
Another group of 2? Do they share any other factors?
No.
Mm-hmm.
Oh, 3.
Yeah. So
It's gonna be the
instead of doing a sloppy circle, I'm just going to put an underline.
You could,
Or I could do a crazy circle, but if needed.
right there.
Or I could have done the 3 at the end. It doesn't matter. So then my greatest common factor
It'd be 6.
is 2 times 2 is 4. 4 times 3 is
12.
12.
Would be 2 times 3.
Because you have 2 2s.
Oh.
So you have a group of 2s and a group of 3s. So we circled a 2, and a 3. So we multiply those together, we get 12. So now we're going to look at our variables. U. Kijan, what's the u with the smallest exponent?
U square.
V. Do they all share a v?
Yeah.
Smallest exponent?
6. No. Yeah. It'd be 6.
No.
Be 7.
1.
Look up there again. Compare each term. You have v to the 7th. You have v. The v is attached to the w. It kind of makes it look like a long w. And then a v to the 10th. So 7, 1, or 10, which one's smaller?
1.
Okay? And then w to the 9th, w to the 8th, or w to the 5th?
W to the 5th.
All right. And that is going to be the greatest common factor. Box your answer. You are here. Grab your folder. And then grab a calculator from Mr. McFarland. I guess I could get up and not be lazy, huh? Move this stuff out of your way. Okay. Moving on to the back side of 421 opener. So this is the new stuff. Now, Remember, anytime you see a set of parentheses, and we're doing area models, the parentheses refer to the height and the width. The first set of numbers are going to be our height. The second set of numbers are going to be our width. If you're just given numbers without any parentheses, that's going to represent the rectangle area. So the areas go to the bottom of each rectangle. When we have something like this, we fill in the information that we know first. So looking at this, the information that we automatically know is the height of the first section of the rectangle. So what's the height of this first section of the rectangle? Say again? Okay. I know nothing about the height of this rectangle, and I know nothing about the widths of these two rectangles. So then I come to the areas. I plug the areas in. So what's the area of my first rectangle? Okay, what's the area of my second rectangle? We don't know yet. What about the area of my third rectangle? Why not?
Two ends supposed to go together and get 23.
Good. So we're going to come back and figure that out. And the area of my last rectangle?
12.
Okay. Now with this information, I'm able to find a little bit more about each of my rectangles. What can I find now? Tanisha?
You can times into and get your width part.
Yeah. So I know the height of my first rectangle. So I can take my height, 2D, times something to get the width of this first rectangle since I know the area. So looking at it, 2 times what gets me to 5? 2 times what gets me to 10? 5. I have 1D up here. How many do I need? I need 1 more. So I'm just going to be 5D. So what's the width of this rectangle? If I know the width of my top rectangle, I should know the width of the bottom rectangle, the one that's directly below it. Remember, your width always goes second. Okay, do I know anything else?
Your second one's going to be a 2D.
Yeah, I know the height of my second rectangle. Okay, anything else?
No.
Okay, so from here, I need to determine the factor pairs of 12. Remember, factor pairs. What can I multiply together to get 12? So what all numbers can I multiply together to get 12? So I'm going to make my list over here. So we're going to do 6 and 2. So I'm going to do that backwards as well. 2 and 6. What else?
12, 2, 3.
I'm sorry, 12 and 1.
1 and 3.
1 and 12.
2, 2, and 3.
I'm only going to do factor pairs. Pair means 2.
4 and 3.
4 and 3.
3 and 4.
3 and 4. Oh, we have all kinds of numbers to try out. Okay. So instead of writing in and having to erase a whole bunch, I'm going to do my multiplying over here. So I'm going to do my scratch work over to the right here. So I'm going to take 2 times 6. What does that equal? Anybody?
2 times
So 2 times 6. And then 5 times 2. 12 and 10. Does that, if I add them together, does that get 23? Nope. So it can't be that one. Okay, so I'm going to go down to my next factor pairs. 2 times 2. 5 times 6. 30 plus 4. Too many. Okay, keep going down my list. So now what numbers am I going to use? Okay, 2 times 12.
24.
Already too many, right? Because we're trying to get to 23. Scratch that out. 2 times 1. 5 times 3. 2 plus 15. Not enough. All right? Of course, it's going to be one of these. We have to do a whole bunch of work first. So 2 times 4. 5 times 3. 8 plus 15. There it is. So what number do I plug in here? 4. Good. I'm going to plug in the first factor, which is 4. So then the second factor I'm going to plug in is 3. Bless you. And now I can go ahead and find the rest of my areas. So 2D times 4.
8D.
3 times 5D?
15G.
So then if we take 15D plus 8D, we will in fact then get 23D. All right. Oh, I didn't use the right color for that. What else can I fill in now?
The last box.
Okay, the last box, the height is,
3.
the width is.
4.
Okay, am I done?
No, he has right up top.
3
Yeah.
times 4, and then you have to put 4 at the top of the box.
Good.
And then you have
Show
to
my
put it
width,
inside.
the top of my box. Show my height for the last rectangle. Now I'm ready to do the final step. So what's my other height? So I'm going to have 2D plus
3.
3. My first width
That would be 5D.
plus
4.
4. All right. Pull over your second opener. So the one that's dated 4/24. So 4/24. You guys all ready? You getting these, Alyssa?
Huh?
You getting them?
Yeah.
Okay. All right. Here we go. Just kidding. All right, I guess I'm going to squeeze that all in there. All right. Oh, I don't want to squeeze those all on in there. How would you guys feel about skipping that part?
Okay.
All right.
So I did all this work for nothing.
I wouldn't say nothing. If you got it right, do you have them all done?
I'm on the second one.
All right, maybe I'll give you a little extra credit for the one if you got it, the first one right. Okay, so let's just do this backside. So we have 8x squared y cubed plus, I don't know, equals 32x squared y to the 5th minus 24x to the 5th y to the 3rd. Let's see here. What does this part represent? Zach,
The answers in the box.
what's the answers to the box mean though? What's that called of the rectangle?
The area.
The area. So I'm going to plug in my areas first. I'm just going to mix it up a little bit. So I'm going to plug in my area. My first area is what?
32x squared y to the 5th.
Okay, and the second area?
24.
What kind of 24 is that? This is where those pluses and minuses are going to matter. What kind of 20? Ne-
24x 5th. 3. I don't know.
X to the 5th, y to the,
3rd.
or you could say y cubed. Okay? What do I do with this number out in front? That 8x squared y cubed. What does that number represent, Paige? Ah, I should have been listening to Miss Litigan. The height, yeah, you have it. So we have 8x squared y cubed. So what do I need to find out here? What do I need to find out yet? Dylan? What don't I know?
The width.
Yeah, the width. Do I have any guesswork in this one?
Yes.
Like the extra guesswork? No. So this is going to be a pretty easy one. So I'm going to go ahead and put the height
This one.
in each of my rectangles. So 8x squared, y to the 3rd. I write big. So what I do, I put my width down below. So again, I'm going to put 8y squared, or sorry, x squared, y to the 3rd times something to get me to negative 24x to the 5th, y to the 3rd. Now, the previous openers, you guys were able to quickly tell me the coefficient and the variable that I need to plug in for the width, but now I'm working with more exponents and more variables. So what I want you guys to do is first determine what numbers do I need. So what number do I need to multiply 8 by? So 8 times what will get me to 32? Oh, I gave somebody my pencil yesterday. So 8 times what will get me to 32? Huh?
4.
4. So now, I have x squared up here. I have an x squared down here. So do I need to multiply the number by any x's? No. If I have them here and I have them here, I don't need any more. So then I go to my next variable, y to the third. So I have 3 y's up here, but I have how many down here? 5. So how many more y's do I need? 2. So I'm going to have to multiply it by y squared. Okay? So the width of this section of the rectangle is 4y squared. You asked me a question. We'll get you. I haven't forgotten you, I promise. So now I have 8x squared y to the third. So this height times what width to get me to negative 24x to the fifth y to the third. So the first thing I'm going to think, 8 times what gets me to negative 24?
-3.
Negative 3. So now I'm going to look at my variables. I have 2 x's up here, but 5 down here. How many more x's do I need? I have 2 here, I need 5. I have 2, I need to go to 5, so I need 3 more x's. So x to the third. I have
That's it.
y to the third, y to the third. I don't need any more. So what's the width of that rectangle?
-3.
Okay?
But why do they have a plus sign?
Okay, there's 2 ways that we can write this. Actually, if you were to write this in order, what should go first and why? Cubed, why? Not because it's a negative. Zach?
Because the X comes before the Y.
In alphabetical order, and not only that, but because it has 3 exponents. It has the most exponents. So, you will not get it wrong. So if you chose to write the 4y squared, then plus negative 3x to the third, it would not be wrong. The correct way to write it, though, would be, in fact, negative 3x cubed plus 4y. Either way would be acceptable. Okay? And that is it.